Okay, so this video is just a quick comment about number 22 in section 3.5. This is kind of a common error that I see in this section. Um, that is when we work through the roots to the characteristic equation in this problem, we see that the roots are minus 1 plus or minus I, right? And so therefore y sub h, right, would be c, let's go ahead and put out the e to the minus t in front. C1 cosine of t plus C2 sine of t. Okay, and then we would take 3e to the minus t as our first forcing function, so our first guess would be ae to the minus t. And then the second part of this is to work with these two functions, and actually you don't have to break these into two. Actually, it's probably better just to solve it as a one problem, because you have an e to the minus t cosine of t and an e to the minus t sine of t. They go in pairs, and so you can think of this as the output of a single polynomial of degree 2 times the sine and cosine. And so your guess in this case could just be a polynomial of degree 2. Let's go ahead and take out the e to the minus t. I'm going to need one polynomial of degree 2 for the cosine, and then another degree 2 polynomial for the sine. Okay, and then I do notice that the constant part of this is part of the homogeneous part of the equation, so I need to multiply my guess by t. Good. And so what I wanted to mention here is the following. Maybe I'll say it this way. Let me pause this. I'm going to write down two expressions. I'm going to see if they're equal or not. So in this case, I'm taking a look at these two expressions here. Are the expressions at plus b times c cosine of t plus d sine of t, is that expression equivalent to saying at plus b times cosine plus ct plus d sine? You see why we're looking at this? Because in this case here, we're thinking about a polynomial of degree 1, right, times a cosine, and a polynomial of degree 1 times a sine. And so in the method of undetermined coefficients, right, we say that this is the expression that we want, right, if we want a polynomial of degree 1. In this problem, we were using a polynomial of degree 2, but I just simplified it a little bit. Okay, so is this the same thing as taking one polynomial of degree 1 and then a c times cosine plus a d times sine? Because a lot of people, what happens the first time through these problems, people tend to think that these two expressions are equivalent to each other, but they're not. And I wonder, do you see why? Because in this first problem, or in this first statement here, you're assuming that because you have a c here and a d here, you're assuming that the two polynomials of degree 1 that you're using here are just constant multiples of each other. But down here in the second expression, this at plus b and the ct plus d have nothing to do with each other, right? And so these two polynomials of degree 1 are completely independent of each other. Okay, so these two expressions are not equivalent. And so when we're talking about multiplying a cosine and a sine by a polynomial of degree 2, we need a distinct polynomial of degree 1 or 2. In this case, this is degree 1. But in the problem up here, it was degree 2. But that's not, you don't want to just use one polynomial and then multiply by constants in this cosine and sine. You have to have a distinct polynomial for each of your sine and cosine. Okay, so that's all I wanted to say on that one. Let me know if you have any questions about section 3.5, number 22.